Hello everyone, welcome back to video. So today we are going to see problem number 2787, ways to express an integer as a sum of powers. So let's read the problem and understand it. Given two positive integer n and x, written the number of ways n can be expressed as the sum of x power of unique positive integer. In other words, the number of sets of unique integers. So here we need to find unique integers that power of x will give the summation of n. And there can be multiple ways of creating such unique combinations. Okay, so we'll need to return that. Since the result can be very large, return its modulo they have said. Okay, so we'll go to the board and see how we can understand the problem in deep what we need to find. So here I have written in words like what we need to exactly find. The count of ways we can produce the n value with the sum of unique integer power of x. So for this example, we'll see what we are going to see. Okay, so we have n equal to 10. We need to form 10 with the power of 2, like squares of unique numbers. Okay, so we'll see 1 square will be 1, 2 square will be 4, 3 square will be 9. Okay, and 4 square will be 16. As we got 16 that is greater than 10, we cannot take 16 and we cannot move forward with this because we'll get a higher number only every time. So we can include only these three. So with these three, I can only see one possible combination, that is 1 and 3, that give us a 10. 9 plus 1 10. So the answer for this problem is 1. So for this, I see we can make through dynamic programming. We can solve this by dynamic programming, and we need to make a TP array. And in this array, we will store the number of ways for each value, and we'll be possibly moving for every x power value from 1, 2, 3. So here I have taken an example n equal to 4 and x equal to 1. So here we'll make a DP array as I mentioned. So DP array is the count of ways we can produce the ith index value with the sum of the unique integers of power. So here we can see 0, 1, 2, 3, 4. So at the end of the iterations, we'll see like how many zeros we can produce, how many ones can we can produce with this sum of the unique integer of power of x. Okay, so let's go through the iteration and understand it. So this is the index and this will be the initial DP array. Initially for 0 it will be 1 because when we consider nothing we will get 0. If we consider anything we cannot produce 0. Okay, then we will be having I equal to 1. For that the value will be I raised to 1 because x is 1 and it will be 1 only, and we will move from right to left and we'll see for 4 can we have can we make 4 with 1. The answer is no because there is no 3. 3 is still 0. Okay, so for making 4 with 1 we need a 3, so we're just adding both of this is 1. So similarly we'll add first this, then this for 3, again we are getting a 0, then this for 2, again we are getting a 0. But for 1 we can produce this by adding this, like dp of 1 minus dp of 1 minus val. So value is 1, so dp of 0 plus dp of 1, we are getting a 1, and this is the dp array after iteration 1. The next we will have iteration 2. So here we'll see if we can make 4 with 2. No, we cannot make because our 2 is already 0 in the previous array. We need a 2 to make a 4, correct? So, and that's another reason when we are traversing from right to left, because if we have traveled from left to right, this 2, we could have got a 2, right? And we would have added it here. And at that time, when we come to 4, we'll get an answer as 1, but we have included 2 plus 2, so it will not be a unique, we are adding it 2 times, correct? So we are to avoid this, we are traversing from right to left. So for this 2, 4 we cannot make with the help of 2. Then we go to 3 and we check if 3 minus 2, that is 1. Okay, 3 plus 1, 3 plus 2, we are getting it, so we are adding it. Okay, then again with the help of 2 we'll see we can make 2. Yes, we can make 2 with the help of 2. So we'll be adding dp of 0 plus dp of 2, and we'll get a 1 here. Again we'll check 1, and 1 it will come out of the loop because 2 is greater than 1, somehow or the other we are not able to produce it. Then we will see I equal to 3 and value will be 3 only. So we'll see if we are able to produce 4. Okay, so we'll considering the previous array for that. Okay, so 3 minus, okay, 4 minus 3, that is 1. We need a 1, 1 plus 3, yeah, we have a 1. So we added these both and we get this 1. Okay, similarly we can produce a 3 just by adding nothing and 3 taking 13. So we are just added 1 to it and we get a 2. Similarly we are doing for other iterations. So hope you get it. Like, let's see the last iteration, that is I equal to 4. With the help of 4 value we can produce a 4. So previously we are able to produce it once and we're just adding 1 to it, so it will become 2. And other than that we cannot produce anything with 4 because all the numbers are less, and we will stop the iteration here and we return the answer as 2. So our answer is 2, and we will return dp of n, dp of n in this. So let's write a code for it. So here we will taking one mod first, d mod equal to, and 7 whatever which is given. Then we'll take a long dp, okay, because sometimes it can be greater and it can go and overflow that int number. So we're taking a dp for that into new int, and we'll be taking n plus 1. Okay, we need to find the exact number, possible values, correct? Yeah, then we'll be iterating from I equal to 1 till I is less than equal to n and I plus plus. Okay, also initially we'll be marking dp of 0 as equal to 1, because if we consider nothing we'll get 0. Then for this we'll be again iterating for int j equal to, we will be taking this value. Okay, sorry, I forgot to take this value, int val equal to math dot power. Okay, math dot power of n comma x, sorry, I comma x. So this is our power value that we considered for this iteration, and if value is greater than the n, we break it, we just break it, and j will take as n, and j should be greater than equal to 1 and j plus plus. Okay, oh sorry, j minus minus will do, and j should be greater than, let me think, j is equal to n and j should be greater than value, exactly, greater than equal to value. Because if it's less than value, what is the point of going and iterating through the whole array, like we saw in the previous example in the iteration, correct? And then we'll write dp of j equal to dp of j plus dp of j minus val. As we saw in the iteration, correct, we will be minusing the value and seeing if that value and this gives us a j, and we'll be adding it both, and just simply we'll be returning dp of n. Okay, and let's try to run this and see. mm, math.pow, I think p is capital here. Okay, it can be it should be long. I think p was right, and then other thing, new int, sorry, I wrote int here, my bad, and dp of n. Okay, I will just typecast it. j minus val. Okay. Oh, okay. Here also I need to typecast it. 90. Oh, I forgot to do a modulo. MOD. Conversion of. Okay, I'll just do one thing. I'll just typecast this directly, so I'll get an answer and I'll remove from here. It was actually double and I made a long, so I'm getting an error. Okay, so code is working. Let's try to submit and see. Okay, great. It's passing everything. So here the time complexity will be. See, one we are running a loop from I to n. Okay, so that will be n, and the internal loop will be running from n square, not n square, n raised to x value, root of nx, we can say. So n root of nx will be the time complexity, and the space complexity will be n again. So thank you for watching the video. Hope you liked it. Please comment down if you have any problem, and I will try to help you.